So today we're going to be starting out trigonometry. Now, trigonometry GCSE Maths is one of the most important topics that we have to learn. It involves a total of 4 to 5 components that we have to learn. The first one being the types of triangles we need to know about. Okay, so first of all, types of triangles. Now, first of all, you have this triangle. It's called an equilateral triangle, the first one, equilateral triangle. In equilateral triangle, you have all the sides and all the angles equal. All sides and all angles are equal. So you have this angle, you have this angle, and you have this angle. You have 3 angles in the triangle. So all of them will be 60 degrees. But why 60? I'll explain that. But first, you just write down 60, so it's all the same. And same as for their sides also have to be the same. So let's say it's going to be 10 centimeters, 10 centimeters, and 10 centimeters. Okay. So our rule was that all sides and all angles will be the same. Okay. And the reason for all of the angles being 60 is because angles inside a triangle have to add up to 180 degrees. Now look, if all the angles have to add up to 180 degrees and we have 3 angles over here, we have this angle over here, this one here, and this one over here. That means our total is going to be 180 divided by 3. That gives you 60 degrees on each angle. Okay? So that's what the reason for this is. Now the next type that we have is our scalene triangle. Okay, the scalene triangle, let me first make it here. It's going to be something like this, where every side, or let me erase this first. Yeah, something like this. So a scalene triangle is where all sides and all angles are different. So it's the exact opposite of your equilateral triangle. In equilateral triangle we had, if you go up, all sides, all angles are equal. And over here, all angles and all sides are different. Okay? So that's what a scalene triangle is. If you have, let's say, this angle over here as 41 degrees, this angle over here as 65 degrees, okay, then the remaining one is going to be 70, 74 degrees. Because they all have to add up to 180. So 41 plus 65, that's going to be 106. And 106 plus 74 is going to give you 180 degrees. So that's what this. And same for the sides. The sides that say are 10 centimeters, 8 centimeters, 7 centimeters. That's an example. Okay. So all angles and all sides are different. Now, why are we learning the different types of triangles to begin with? Because later on we're going to do the different rules, the Pythagoras, sine, cos, tan, cosine, sine rules. Okay, we need to know the way these are applied. Okay, so we will use the types of triangles to see, okay, I can apply this rule on this type of triangle. I can apply this rule on this triangle. So we should know first which triangles are we working with. Okay, so that is that. Now the third one is a isosceles triangle. Isosceles triangle. Okay. Now, in isosceles triangle, it's a bit, you could say it's very similar to the isosceles, sorry, the equilateral triangle, where it'll be like this. Let's say this side over here is 40. This side is also 40. And this side is going to be 100 degrees. Okay. And let's say this side is 10 centimeters. This side is 10 centimeters. And this side is 8 centimeters. It is an example. In an isosceles triangle, you will have two sides and two angles the same. Remember in an equilateral triangle, if you go up again, we had all sides and all angles same. And in isosceles triangle, we have two angles and two sides the same. So it's really almost the same thing, but a bit different. And I'll share with you a rule that there's a very specific case where an isosceles triangle can automatically become an equilateral triangle. Okay. But before that, let's write this down. So two angles and two sides are the same. And as always, these notes are going to be in the description. You can use the notes for your revision as well. Now, so two angles and two sides are the same. Now there's one case that I have to write down. In one case, the isosceles triangle becomes an equilateral if one of the angles is 60 degrees. What does that mean? Let's take an example. Let's go a bit down. So let's say over here, I have this triangle, okay? Now, let's say I take this angle as 60 degrees. Okay, that means that the angle that's facing is going to also be 60 degrees because it's an isosceles triangle. Now, we also learned that angle in a triangle have to add up to 180. So that means the remaining one is also going to be just 60 because if we have 60 here and 60 here and they both have to be the same, so because this 60 and this 60 have to be the same because of the isosceles rule, then the remaining is also going to be 60 because they all have to add up to 180. So what all the angles are the same, all the sides are also going to be the same. So we're going to have, let's say 10, it's an example, 10 centimeters, 10 centimeters, and 10 centimeters. So that's a very specific case. If you have one angle as 60 in this isosceles triangle, it's automatically going to make the entire triangle into an equilateral triangle. Okay. Now, the fourth type we have is we did equilateral, we did scalene with the isosceles, and the right one is the right from the last one, right angled triangles. This one is the one that we're gonna use the most because many of the rules are applied to this specific triangle. So let's first make the shape. It's gonna look specifically like this. You will have a right angle over here. This. On this side, you're gonna have a square made that's gonna signal a right angle. What does this mean? This means that you have 90 degrees over here. Right angle means that it makes a right angle, meaning a 90-degree angle. Okay? Right angle means it makes a 90-degree angle. Okay? Now, let's first go a bit down. Now, there's one thing to keep in mind, that in each triangle will also so those are the different types of triangles we have. We did equilateral, scalene, isosceles, and right angle triangles. In the next class, we're going to learn where do we use these triangles and what different types of rules can be applied to each triangle within the rules that we learn in trigonometry. Okay?